next to you. So let's tackle another one together. All right, so I make my little X diagram. The number on the top is not just the -5. It's A times C. All right, it's the A times the C value. So it would be what? -15. -2 is on the bottom, just like it always was. I'll keep that in red. All right, so give me two numbers that multiply to -15 that also add to -2. 5, what did you say? -5 and 3. I thought I heard 5 and 3. All right, once you get those numbers, that's key to everything. Once you get those numbers, the problem's going to solve itself, because I'm going to say 3x squared. You could write it as plus negative, or you could just jump right to the minus 5x plus 3x minus 5. And again, doesn't matter what order you go in. So if I put the plus 3 here, plus 3x, and then minus 5, you're still going to get the same answer. All right. And I believe, I mean, I can't think of a case off the top of my head, I believe with equal level of difficulty. So really, it's a technique you can't go wrong with. All right. So GCF for the first part would be what? All right. Which is perfect, because the other part is 3x minus 5. If I know they have to have matching factors, so this factor has to be the same as this one, what would the coefficient have to be in front? A 1. We'll write it as a positive 1, just to have that addition. Now I have the common 3x minus 5. Pull it out. 3x minus 5 times x plus 1. Poor quality box, fixing it. That's it? No, like less than 100.
Ooh, stupid. Hey, we're in the middle of the problem. Actually, no, we're not. Works.
I had a sneaky feeling.
Yeah.
All right, so again, we're taking the A value and multiplying it by the C value. Now, something to be mindful of. We were always doing that. The top number within the X chart was always A times C.
You're right.
But the A value is always a 1, so it didn't matter. Right? So it is these two values multiplied together. So a -20 in this case, with a 19 on the bottom. So again,
That's a 20 and a -1.
20 and -1.
Wow.
Or
-1
-1 and
and 20.
20, because it won't matter which order you do it in. So 5x squared plus 20x minus, I'll write minus 1x minus 4. Partition, right down the middle. GCF?
5. X.
5x. Then x plus 4. Now we know that the binomial has to be the same left side to right side, so I know I'm looking at another x plus 4. What would have to be what would the coefficient have to be there?
-1.
-1. I now have a common x plus 4 that I could pull out, and that would leave me with a 5x minus 1. You know, trial and error could get you there. You know, you look at this and you say, all right, two numbers that I know that'll add to equal 19. I mean, it's not as simple as 8x, because 19, I mean, it could be 18 and 1, 17 and 2. Could be 20 and -1. It could be 21 and -2. It could be 100 and -81.
It's literally infinite, right?
Yeah, there's infinitely many possibilities, but there's some that make more sense than others. If I know that I want to have a common factor involving a 5, then I'm looking for some pair of values, one of which is some multiple of 5 that will add to equal the 19. So then you might say 15 and 4. You know, try that, maybe it works. But the emphasis is on the fact that you're trying that. Here, we have an approach that's going to guarantee it, all right? Whereas before it was trial and error, full-blown trial and error. Now you have an algorithm. You have an approach that's going to allow you to get the answer, and that's wonderful. So let's take a look at number 5. So again, we're following the method that tells us to take the A value This is like the period of weird noises, I think. That one I think is a teacher. That sounds like Rosati.
It is.
It is, right? You must be emphasizing something really important. Like factoring out a GCF or something like that. I tried doing that once, but people got scared. Because I don't have that kind of personality. Like if I raised my voice, people would get frightened. So I don't. I keep it nice and quiet like. All right, so we take the A value and multiply it by the C value. This is me raising my voice, but this is like and it gets all raspy like too. So again, A multiplied by the C value. Bless you. And that's the key there. And I'll take it back in a second to something that didn't have a leading coefficient, just to show you that this technique always works, where you're multiplying the A by the C. Right? So I need two values that multiply to -24 that add to 10.
12 and -2.
12 and -2. All right, so let's say you were unable to come up with that. The way you handle it, and we've talked about this before, but it's not always necessary, so sometimes it's very easy to lose sight of it. You want to take the -24 and put it into your calculator as a graph. So -24 divided by x. The rationale being, and it's really, in a lot of cases, it's not important that you know the rationale, but for some of us, we do like to know why we're doing what we're doing. So if we're taking two numbers, so two numbers multiplied to -24, we could think of that as x times y equals -24. So the equation x times y equals -24. If I solve that for y, I would divide out the x. That would make it y equals -24 over x. So what I get is a relationship between x and y. So anything that satisfies this equation would give me values that actually multiply to equal -24. The reason we have to write it like this and not like this is because the calculator only understands y equals. If I could write it as x times y equals -24, like a lot of online software will allow you to do, like if you're using an online graphing calculator, you just type in x times y equals -24. It knows exactly what you want. These calculators only understand y equals. All right, but then once I have this, I go into my table, second graph, and now I have a list of possible factors of -24. So second graph. All right, that's the key. So it's when you're in this list, I mean, you still got to do some work, but now the amount of work is minimal because all you're doing is you're going across each line and saying, do these two numbers add to equal 10? Do these two numbers add to equal 10? And so on. And it doesn't take long to get to the third item here before you realize, well, yeah, I have two values that equal 10 when I add them together. But we said 12 and -2, so maybe you missed that, the -2 and 12. Maybe it wasn't until you got to the 12 and the 2. We learned yesterday that it's not going to matter whether you put the -12 here, -2 here and the 12 there, or the 12 and then the -2. I'm not 100% sure I said any of that right, but we'll see. I'm trying my best to not like cough profusely here. So 3x squared. I'll change the color a little bit. So plus 12x minus 2x minus 8. Partition it down the middle. Let's pull out a GCF. We'll have a 3x times x plus 4. The other part should also have an x plus 4. In order for it to have a factor of x plus 4, its coefficient would have to be a what? A negative 2. All right? And so by grouping, we have a common x plus 4 times 3x minus 2. And again, didn't matter the order. If I did negative 2, then 12, I would have gotten 3x squared minus 2x plus 12x minus 8. Still would have worked. Partition it down the middle, it's still going to play out the right way. All right. Let me just show you a quick side example, just to prove my point. Well, it's a side example, so I'll do it on the side. I'll come back to that if you're still writing. I'll do something very simple, all right? Something that you could figure out without having to do any fancy technique. All right? Even if you had to do this on trial and error, you would get there pretty quickly, all right? But let me use this new A times C method, all right? The A value here would be 1. The C value would be 6. So when I make my X chart, the 5 goes on the bottom, A times C together give me the top. And that would give me a product of 6. All right, previously we were just saying, let's take that C value and put it on top, but that was only because the A value is equal to 1. In fact, we were doing this all along. It was just that 1 times 6 was 6. The A didn't play any kind of meaningful role in this. All right, but we get to our X chart. We're still going through the process. And again, you may look at this and say, I'm pretty sure I know what it is, but I'm looking at 4 choices and they all look pretty similar to one another. I don't want to take the chance. Don't take the chance. Go to y equals, type in 6 over x. And then look for the pair of values that are going to add to equal 5. And what pair will do that? It's on this screen somewhere. 3 and 2 or 2 and 3. I heard 3 and 2 first, so that's what I'll go with. So we'd be looking at x squared plus 3x plus 2x plus 6. Partition it down the middle. Pull out your GCFs. Factor out the x plus 3. And you get an x plus 3 times x plus 2. Is it a roundabout approach for a very simple, straightforward problem? Absolutely. Do you have to do it this way? Absolutely not. Can you jump, if you know it, can you jump right from here to the final answer? Definitely. Right? But what I'm doing here is I'm proving to you, well, not really proving this. You'll learn about that word a lot more next year. But I'm demonstrating to you that even with a simpler polynomial where the a value is equal to 1, this technique is going to work for you. So,
Can I borrow a
oh, yeah. All right. So what happens sometimes, just coming back here, looking at number 6, is that you get to some crunch, I guess. So, bless you. But you also want to kind of streamline the process a little bit and sort of take some things for granted. So you don't have to write out every single thing, but you do want to write it out. You want to kind of balance everything. You want to write enough detail to get full credit, satisfy your teacher, satisfy whoever. But then you also want to make sure that you're not overdoing it because you don't want to be wasting your time. All right. So my X chart, if assuming you even need the X chart, would have a negative 72 up top because that's the product of the A and the C values. I'm not drawing arrows anymore. On the bottom, it's a negative 21 because that's the B value. All right. Now here, I mean, you may look at it, I mean, if you come up with 24 times 3 to equal 72. So negative 24, positive 3. Hey, good for you. Otherwise, to the calculator you go, negative 72 over X into your table and start looking around. Doesn't take too far or too long before you get there. You do, you know, I mean, it sounds snarky and obnoxious, and I don't mean it this way, I promise you. You do need to be able to do simple math in your head a little bit. All right? It's, again, not a snarky comment. Like, sometimes you look at like 6 and a negative 12, for whatever reason, that becomes a negative 4. I don't know. Like, sometimes you I mean, we all know how to add and subtract. Sometimes you try it and it just comes out wrong. All right? So take your time with it and be careful. Don't rush through it, because most of the time when people struggle with this, they know the steps they're supposed to follow to get into this table, and then they look at it and say, I can't find the one that works. And I'm like, not only is the one that works on your screen, but it's dead center in the middle of your screen. Like, it's staring you right in the face. It's just the addition is what's bogging them down. So the 3 and the negative 21, I'm sorry, 24 is what we're looking for. All right, so 3 and negative 24. So 2x squared plus 3. I'm going to go blue. Plus 3x minus 24x minus 36. All right, partition it down the middle. We could pull out an x here. That's the best we can do. 2x plus 3. Again, use the factor that you get on the left side to help you figure out the factors on the right side. I know I must also have a 2x plus 3. What coefficient will make that happen? A negative 12. All right, so 2x plus 3 comes out. X minus 12 is left over. And that would be your set of factors. All right, now how do you check it? Because this is important, especially when it comes to multiple choice questions. I like to use the, it's not going to look much like a rainbow, but I call it the rainbow technique. I don't think I'm the only one that calls it that, but I try to use different colors to make it look rainbow-like. If I take the outer terms and multiply them together, the 2x and the negative 12, what would I get? Negative. I can't hear anybody. My ears are clogged. So you just got to say it louder. I think we actually said it softer that time. Negative 24x, yeah. And then the two inner terms together. The 3 and the x, I'll do that one for you. 3x. And then just ask yourself, will these two add together to give you the middle term that you started with?
Yes.
Yeah. All right, so then you're satisfied that your factors are correct. Because you already know that the 2x and the x is going to give you 2x squared. The 3 and the negative 12 is going to give you negative 36. Those are generally not the problem. It's the outer and inner terms. So the outer product and the inner product need to come together through a sum to give you the middle term. If that doesn't happen, then all hell breaks loose. Right? So what people will do, just to kind of develop a little bit of a shortcut to this, is sometimes they'll use a trial and error approach and use this. I mean, I know it's like calling it a rainbow is a little iffy, but they'll use this technique to check their guesses without ever using the X chart. And that's fine. So I could go back to, let's say, I'll do number 2 real quick. So I'm just going to take a stab at it and say, I know it's going to be 3x and x, right? If I'm going to get to 3x squared, it's going to be 3x and x. All right, so let's just take a shot in the dark here. Give me two numbers that you know will multiply to equal -8. Ideally, something incorrect. -6 and 4, okay. All right, so like I said, ideally something incorrect. I want to show you how this is going to help us verify that we didn't do it right. All right, so my outer product, 3x times 4 would give me a 12x. -6 times x would give me a -6x. We ask ourselves, will these add to give us the middle term? The answer is no. All right, so then we can go back and say, okay, well, those weren't the correct factors. This is not always the best way to go, but if you stumble upon it in the first attempt or two, then it could be a time saver. But if it's something that doesn't play out correctly on, it could be kind of a waste of time. All right, so give me something that's a little bit more in the realm of possibility then. Two numbers that multiply to -8. We think -4 and +2. Okay, so let's try that. Rainbow technique. Outer product would be 6x. Inner product would be -4x, yeah? Will -4x and 6x add to equal a -2? Close. Very, very close. Right, it's going to give us a +2. What could I do to these two signs? Switch them, yeah. Switch them around and everything will be fine. All right, so if I switch them around, so make the positive into a negative and make the negative into a positive, and then you would have your set of factors. All right, this method, I promise you, is not for everyone. Because there are some folks that are like, I was understanding the X chart, it was fine. Why are you throwing this nonsense at me? But then there are other people that are like, wait, if I just do that, I don't have to do all this nonsense? That's great. The issue again is -8, not a big deal when it comes to figuring out factors. If I give you -1512, you're like, oh wait, the numbers that multiply to -1512 that also add to -782. Huh. All right, I don't know if guess and check is going to do it for me here. Okay, so that's the idea. So use this, if you like this method, use it strategically. This is your fallback, because this is always going to work. The X chart's always going to work, provided you know what to put in the cusp here. What you put on the top, again, is the product of A and C. On the bottom is B. So basically, A, B, and C are all going to be accounted for in your X chart. It's just a matter of knowing where to place them. If you know where to place them, you're going to be in good shape.